Most people think German excellence is just a cultural trait. They assume it's some sort of genetic obsession with precision, punctuality, and high-quality engineering. But they're completely wrong. Excellence in Germany, it's not a cultural vibe. It's a rigid, 150-year-old technical infrastructure. Welcome to this explainer. Today, we're initiating a high-level systematic audit of what I call Teutonic Machine 1.0. We're going to deconstruct the German economy not as a random collection of businesses, but as a highly engineered operating system. Every success you see, it's a built-in feature. And every failure, it's a system bug. Let's initialize.
Just look at the massive skills versus degree debate happening globally right now. Most countries out there are running their economies on glitchy, outdated interfaces where the education system and the job market barely even communicate. You spend 4 years in a classroom, you graduate, and then you experience this total shock when the real world doesn't actually recognize your theoretical data. Germany, on the other hand, runs a hardwired, high-bandwidth bridge. It's an economic operating system completely designed for coordinated value production. And its source code is so robust that it's survived total physical destruction, hyperinflation, and the volatile transition from steam engines all the way up to artificial intelligence.
So, to really deconstruct how this machine works, we're running a diagnostic audit sequence across 5 main layers. First, the kernel, which is CCI self-governance. Second, dual-core processing, looking at vocational training. Third, security protocols, basically the honorable merchant. Fourth, system bugs, analyzing the glitch. And finally, number 5, system update and patch notes. All right, let's dive into section 1, the kernel, CCI self-governance. Now, in literally any operating system, the kernel is that core program managing both the hardware and the software. In the Teutonic OS, that kernel is the CCI, the Chambers of Commerce and Industry, and the sheer scale and legality of this network is absolutely staggering. In the US or the UK, a Chamber of Commerce is basically just a voluntary networking club, right? Business owners drink lukewarm coffee and lobby for tax breaks. But in Germany, it is a public law corporation. The CCI Act of 1956 hardwired this directly into the system. If you run a business in Germany, membership isn't optional. It's a mandatory, hardwired legal requirement. From the local bakery down the street to massive global exporters, you've got 3.6 million member companies funneled into 79 regional CCIs. You don't opt in, you're part of the system by default. Because literally everyone is a member, the system forces consensus. This prevents what we can call lobbying bloat, where only the loudest, richest corporations get a seat at the table. In fact, the state delegates roughly 80 public tasks, things like issuing export documents, licensing, standardizing exams, directly to the CCIs. They call it indirect public administration. The philosophy here is surprisingly simple. The hardware knows its own limits way better than some disconnected software developers sitting in the capital. So businesses balance their own system resources, which keeps the state totally out of day-to-day micromanagement. This frees up national processing power, letting the central government focus entirely on macro-level policy instead of fixing local bottlenecks. Moving on to Section 2, Dual-Core Processing, Vocational Training. This brings us to the famous German dual education system, which is honestly the ultimate solution to the massive latency problem most economies are facing right now. Think about a standard high-latency OS. A young person spends years completely isolated in a classroom, learning theoretical code, and then faces a massive shock entry into the job market with basically zero practical capability. The Teutonic OS fixes this with dual-core processing. It merges the two environments. So instead of sequentially learning and then doing, apprentices engage in real-time skill uploading. They spend 3 to 4 days a week actually getting paid on the factory floor, executing practical tasks, and then 1 to 2 days learning theoretical code in a vocational school. It's simultaneous processing. To put this into perspective, look at the workforce pipeline. A massive 45% of German youth completely bypass the standard university route. They are hard-coded directly into the dual Büroausbildung. And we're not just talking about filling low-level administrative jobs here. This is about directly acquiring highly specific human capital in over 300 recognized occupations. Everything from mechatronics to IT infrastructure, right down to advanced manufacturing. They establish a professional identity early. This creates a deeply specialized workforce that perfectly complements the advanced hardware utilized by the Mittelstand, which is Germany's backbone of mid-sized, highly specialized manufacturing firms. These hidden champions absolutely dominate global export markets specifically because their workforce is custom-compiled for the exact machinery they operate. Now, let's talk numbers, because the financial mechanics here are absolutely crucial. German firms spend roughly 7.7 billion euros annually on pure training costs. Let that sink in.
But the lead data scientists and CEOs running these Mittelstand firms, they don't view this as a sunk cost. They don't see it as a loss. They view it as a strict insurance protocol against future skill shortages. And the data actually proves them right. Approximately 76% of these investments are directly amortized by the productivity of the trainees during the training itself. Because the apprentices are executing real tasks on the factory floor, they're producing tangible value while learning. It's a highly efficient, perfectly self-sustaining loop.
All right, Section 3, Security Protocols, the Honorable Merchant. Having immense processing power means absolutely nothing if your system is vulnerable to corruption. Every system needs a firewall to prevent the kind of short-term corporate greed that routinely crashes modern Western economics. In the Teutonic OS, that security protocol is known as the Ehrbarber Kaufmann, or the Honorable Merchant. Now, I know it sounds like medieval roleplay, and it actually does have roots in the 13th century guilds. But today, it is a very real, incredibly pragmatic, sustainable business framework. It basically dictates that responsible corporate behavior is literally the most efficient way to maintain a long-term network. You don't cheat your supplier today because you will brick your entire supply chain tomorrow. It forcefully prioritizes generational continuity over quarterly profit skimming. This security protocol manifests in hard institutional rules. For instance, workers literally have a seat at the table. Co-determination rights mandate that company-level works councils actually bargain with management. It's a stabilizing tradition rooted all the way back in the 1918 Stenenslee-Ain Agreement. Furthermore, you have this heavy Mittelstand aversion to debt. Fun fact, in German, the word for debt, Schuld, is the exact same word used for guilt. That is deeply hard-coded into the culture. These hidden champion companies reject taking on massive debt just to artificially inflate growth. They heavily prefer cash investments. They think in decades, cultivating deep, decade-long client trust. And that acts as a massive stabilizing force whenever global financial crises hit.
Time for the diagnostic errors, Section 4, System Bugs and Latency. Look, as a system auditor, I have to be completely objective here. No 150-year-old legacy software is flawless, and right now, the Teutonic Machine is throwing some severe diagnostic errors. This data point, it's basically a blue screen of death. On the macro level, the dual system looks perfectly integrated, but on the day-to-day Meso level, the actual institutional level between the factory floor and the classroom, there's a severe loose coupling issue. A staggering 74.2% of companies do not or seldom actively coordinate with vocational schools. So instead of a tightly synchronized dual system, they're often operating as parallel systems. That creates a massive bandwidth bottleneck where classroom theory is lagging dangerously behind the highly advanced hardware actually utilized on the factory floor. Compounding this loose coupling is what we call the academization glitch. For the first time in the entire history of the German qualification system, the number of young people entering standard university study has actually caught up to those entering the dual vocational core. Gen Z is increasingly favoring the standard prestige-driven university update over the factory floor. They're opting for degrees with broad, theoretical applications instead of highly specialized technical skills. For the Mittelstand, this is a critical error warning. If this highly specialized vocational processing power becomes under-resourced, Germany risks losing the very specific human capital that maintains its status as a global export leader in complex machinery. Which brings us to our final phase, Section 5, System Update and Patch Notes. So, how exactly does an aging industrial-era OS prevent a total system crash in the era of Industry 4.0? Well, the beauty of a self-governing kernel like the CCI is its incredibly pragmatic ability to self-correct based on hard data. We are seeing real-time patches being applied right now. The business community successfully lobbied to establish a national agency for springboard innovations, specifically to tackle disruptive tech. They are aggressively integrating artificial intelligence into Mittelstand workflows, while explicitly rejecting growth-killing proposals like machine and robot taxes. Furthermore, the education system is actively patching that academization glitch by developing highly advanced dual study profiles, things like mechatronics and IT sales. These programs merge the prestige of a standard university degree with the hard-coded practical application of a traditional apprenticeship. Ultimately, the Teutonic Machine 1.0 proves that economic resilience isn't magic, and it certainly isn't a cultural accident. It's the result of meticulously designed, mutually reinforcing institutions. It literally forces capital and labor to share the motherboard. It uploads specific skills in real time, and it enforces a security protocol that heavily punishes short-termism. So the final question you really need to ask yourself is this. Looking at the glitches, the skill shortages, and the unchecked corporate greed in your own country, are you running your economy on a 14-day trial of a broken OS? It might be time to look at the German kernel. Keep questioning the systems around you,